Hello! So in this video we'll look through some basic examples of integrating functions. So just first of all remind ourselves of the process of integration. So remember that integration is just the reverse of differentiation pretty much. They just undo each other, much like adding and subtracting or multiplication and division. So differentiation undoes integration and vice versa. So if I think about the process for integrating a function, then I can just think about it in terms of differentiating and then undoing it. So just remember, to differentiate a function of the form ax to the power of n, I first of all need to multiply by the power, then I need to subtract the power by 1. Whereas when I'm integrating it, I just do the same kind of idea, but I undo it. I do it in the reverse order and I do the opposite operation. So instead of subtracting the power by 1 first, I'm going to add the power by 1. And instead of multiplying by that power, I'm going to divide by that power. So you notice I'm doing it in the opposite order as well. So okay, let's have a look at this function here. Let's integrate root 5 plus 3 all divided by x cubed with respect to x. That's all the dx means. Remember, it's just a tiny infinitesimal change in the x direction. So I'm doing it with respect to x. Okay, so first things first, much like with differentiation, I need to see if I can write it of the form some number times x to some power. So kind of like this, okay? Well, you notice that I can write this, because I've got root 5 plus 3 and I'm dividing it all by x cubed, I can separate this. I can write it as root 5 over x cubed, and I can write it as 3 over x cubed. And I'll integrate all of that with respect to x. Now just remember, if I'm dividing by x cubed, that's the same as multiplying by x to the negative 3. It's just using power laws to work this out. So the integral of root 5 times by x to the negative 3 plus 3 times by x to the negative 3, and I'll integrate all of that with respect to x. Don't forget the dx, by the way. That's a common mistake when people are working with this. They leave the dx on. That's actually really important, because ultimately what you're doing is integrating with respect to x. Okay, so that's really important to keep the dx there. Okay, so far I've just been simplifying and rearranging stuff. I haven't actually done any integration. So now I'm in a position where I can actually do the integration because I've got it in the form that I want. So okay, I'm going to look at each term separately. So in this case, I've got root 5 times by x to the negative 3. So if I integrate, I first need to add the power by 1. So I get x to the power of negative 2. Remember, negative 3 plus 1 is negative 2. And then I need to divide by that power. So I need to divide by negative 2. So in this case, I get negative root 5 over 2, because of course the negative 2 makes the whole thing negative. Okay, fine. Now if I look at the second term, if I raise the power by 1, I get x to the power of negative 2. And if I divide by that power, well, I get 3 divided by negative 2, which I can write as negative 3 over 2. Now, the only thing to add here is a plus c. Now, this constant of integration, the plus c, just basically uses the idea that integration and differentiation are reverses of each other. They undo each other. So the idea is that if I take this function and differentiate it, I should get back here. And indeed I do. However, this plus c basically says, well, actually, if you remember, if I have like a plus 2 or a plus 3 or just plus any number, when I differentiate it, that number will just go to 0 anyway. So I need to account for the fact that, yes, it is true, if I just wrote that down, I would get back here. However, it would also be true that if I add any number to this, I would still get back here when I differentiate it anyway. So that's the reason why I add the plus c. If you're interested, this thing is called an indefinite integral. The reason being is because I have that plus c there. If I had some other information, for example, when x is equal to this, y is equal to this, then absolutely I should be able to find the definite integral. I should be able to find what that plus c is. And in fact, the second situation we're going to look at in just a minute is going to be a definite integral. But because I have that plus c in there, it's indefinite integral. Okay, fantastic. Now, can I do any simplification here? Well, okay, I am just going to rewrite the x to the power of negative 2 as 1 over x squared. So in other words, I'm going to leave my final answer as negative root 5 over 2x squared, because of course that's x to the power of negative 2, 1 over x squared, minus 3 over 2x squared, plus c. And then you notice that both things is over 2x squared, so I should just be able to write this as negative root 5 minus 3 all divided by 2x squared plus c. Okay, and that would be how I would leave my final answer. Okay. Okay, so let's have a look at this question then. This question is slightly different because we have limits. In other words, it's a definite integral. We're not going to have the plus c at the end. Okay, so first things first, let's rewrite this so we can integrate it, excuse me. Okay, so we can write this as the integral between 1 and 5. I'm going to write, root x to the power of 5 as x to the 5 over 2, but I'm going to make it negative because it's 1 over, okay? And I'm going to integrate that with respect to x. Okay, so just remember the process to integrate something. I first of all need to add 1 to the power. So if I take negative 5 over 2, add 1, which is effectively the same as adding 2 over 2, I get negative 3 over 2. Then I need to remember to divide by that power. So if I divide by, it's going to become 1 over negative 3 over 2. Do a bit of rearranging, that's going to become negative 2/3 x to the power of negative 3 over 2. Then I'm going to add c for the moment, okay? So I'm going to add c even though I know I'm not going to need it at the end. You don't have to write the plus c in at this stage because you realise that you're not going to have it. That's fine, you don't have to write the plus c in. I just am just for good practice, so it makes sure that I'm not going to forget it, okay? Now just remember that this thing here is an area function. In other words, it literally says, find me the area between the x-axis and this curve, okay? So this is my area function, it will allow me to do that. So in order to find the exact area, I'm going to put my limits in. So I put my square brackets in, then I just copy these limits down. So I've got my 1 and I've got my 5, okay? So all I need to do is first of all stick in 5. That's going to find me the area from negative infinity right the way up to 5. But before I'm going to do that, I'm just going to rewrite this x to the power of negative 3 over 2 as well, okay? I'm going to write it as negative 2 over 3, and then I'm going to write that as, well, it becomes 1 over square root of x cubed. Okay, so I write that as square root of x cubed plus my c. Okay, it's just a little bit of rearranging on that thing there. Okay, now I'm in a position. If I stick in 5 first of all, I find me the area from negative infinity all the way up to 5. So let's stick that in. So I get negative 2 over 3, and then if I stick 5 in, I get root 5 cubed. Okay, so that's my first thing. And of course plus c, don't forget my plus c in this case. And I'm going to take away the area of all the way up to 1. So I'm basically just going to stick 1 in. So negative 2 over 3 root of 1 all cubed plus c. Okay, now I'm just going to stick all of that into a calculator, but you notice this is the reason why we don't need the plus c when we've got those limits, because the plus c and the minus c, because I've got the minus in the middle, will just end up cancelling out. So effectively it will just become negative 2 over 3 root 5 cubed, take away negative, so that becomes a plus, 2 over 3 root 1. All cubed, okay? Because of c's just cancel. So if I stick that in a calculator, then it should come out as about 0.61, providing I haven't made any kind of calculation errors, okay? But just remember, when you've got limits, it's a very, very simple idea. You first of all stick the top limit. Well, first of all, you do your integration. Then you stick your top limit in, then you stick your bottom limit in, and then you take them away from each other, okay, in that order. So in this case, the answer is 0.61.